So with 5.4, this is the last lesson in this little section that we're going to have before our test. It's not the end of chapter 5. We're going to continue chapter 5, but 5.4 is the last one before the test. So we're going to look at long division of polynomials and synthetic division, okay? So if we think about long division, you learned that either in 3rd or 4th grade. So we're going to go back to just integers so you know and remember the steps for long division, then we're going to apply that for polynomials, okay? So if I have, let's say, 153 divided by 2. Okay, what are my steps to do long division for that? I would see how many times 2 can go into what? 15. How many times can 2 go into 15? 7. And what would I do with that 7? I would multiply it by the 2, and I would put my 14 under the 15, and then do what? Subtract. 15 minus 14 is a 1. And then what would I do after that? Bring down the 3, and then do it again. How many times can 2 go into 13? 6. And then I would take that 6 and do all those steps again. Multiply 6 times 2 to give me 12. I would subtract it. That would leave me with 1. What is that 1 called? The remainder. I'm just going to put an R. That's your remainder. And then this 76, you know what that's called? What's the answer you get when you divide? The quotient. Okay. The number you start with is your dividend. The number you divide by is your divisor. Okay, I'm writing those out because they both start with D. So when you do your long division, when you just did this in elementary school, you probably did 76R1, remainder 1, okay? So now how you're going to do it, you're going to write your answer in the form of quotient plus remainder over your divisor. Okay, so if we applied that to the example that we just did with just integers, then we would have our quotient 76 plus our remainder of 1 over our divisor of 2. Okay, now that's really simple and quick when you do it with just integers. With polynomials, you will have x's thrown in there and it will look a whole lot more than just this, okay? So if we're starting with our first example, I've got in parentheses 3x squared minus 11x minus 26, and that's being divided by x minus 5. So your first step is always to check, is it in standard form and do I have missing terms? If you have missing terms, you're going to substitute zeros for those placeholders. Okay, so that way everything lines up when you do your long division. Okay, so if I have 3x squared minus 11x minus 26, it is in standard form. I don't have any placeholders. So I am going to set up my long division. That dividend goes inside, and that x minus 5 goes over to the left. So when you're doing your long division with polynomials, you're only going to look at your first term. So I'm only going to look at that 3x squared and that x. Okay, so what I'm going to do is over to the side, I write that 3x squared divided by x just so you can see just those two terms without everything else added onto it, okay? You don't have to do that, but that might help you. So if I'm dividing 3x squared divided by x, what does that leave me with? 3x. So I would take that 3x and I line it up with the like term of the dividend. So I put it over that negative 11x so that my placement lines up, okay? So when I take this 3x, this is like the 7. The 7 I multiplied by 2 and put the 14 under. So now I'm going to take this 3x and I'm going to multiply it by the entire divisor. So you multiply it by x and negative 5. So that's going to give me 3x squared minus 15x. Now, when I did this 14, I subtracted it. So I have to subtract the entire 3x squared minus 15x. When I do that, when you subtract, you change the sign of the polynomial you're subtracting, if you remember that from 5.2. So this 3x squared is going to become a negative, and this negative 15x is going to become a positive. You can either change the signs within your problem or just read 3x squared minus 3x squared negative 11x minus negative 15x. I personally like to just change the signs and then just cover up the minus and do it vertically. Okay, so then 3x squared minus 3x squared cancels. Negative 11x now plus 15x is going to give me a 4x. And then I bring down that minus 26. Did y'all follow that, all those steps? Okay, so now we do those steps again. We're just now looking at this 4x. So I'm going to have 4x now divided by x. And what does that leave me with? Just a 4. And if you notice, my next term should be a constant if I'm going in line with my dividend. So it's a positive 4. I put plus 4. And then I multiply 4 times the x minus 5, and that gives me 4x minus 20. Now I have to subtract that off, and when I subtract, again I have to change the sign, so it becomes a negative 4x and a positive 20. So 4x minus 4x cancels. Negative 26 plus 20 leaves me with a negative 6. Now, that's very clear that that's my remainder because it's a constant, but not every single time we have a constant as a remainder. Sometimes it's going to be another polynomial as a remainder. As long as the degree of your remainder, which is your exponent, is less than the degree of your divisor, and you've filled in everything you can in your quotient, then you can stop there. Okay, so for this one, the negative 6 is my remainder. That 3x plus 4 is my quotient. And the x minus 5 is my divisor. So when I write my answer, I have quotient 3x plus 4. Now, if I go with this form, I should have a plus, but I have a negative 6. And nowhere in Algebra 2 we're going to have a plus negative. So we're going to take that negative and make it a minus 6 over our x minus 5. And that would be the way that I write my answer. Okay, are we good with that? Do you have questions? So that's something that you would have seen in Algebra 1 because long division is discussed in Algebra 1. Now, this next example is a little bit longer. We have 3x to the 4th minus 5x cubed plus 4x minus 6 in parentheses. And then instead of a division symbol, we have another set of parentheses with x squared minus 3x plus 5, and that is raised to the negative 1 power. Okay, now we're going to have exponent rules in chapter 6, but you did learn exponent rules in Algebra 1 also. If you have a negative exponent, that means you should be doing the reciprocal of that term that's being raised to the exponent. So what this really means is that this should really be in the denominator of a fraction. So if I'm thinking about these two things being multiplied, really what it's saying is I have 3x to the 4th minus 5x cubed plus 4x minus 6, and that is being divided by my x squared minus 3x plus 5. So instead of writing a division symbol, having it multiplied by a polynomial with a negative 1 exponent is just another representation of telling you you are dividing. Okay, so you're just having multiple representations here. So we're still going to set it up. When I set it up, I'm going to check, is it in standard form, and do I have all my terms? Okay, if I look at my dividend, 3x to the 4th minus 5x cubed plus 4x minus 6, is there anything I need to do with that? Do I have all my terms there? No, I do not. I have x to the 4th, x cubed, but I'm missing an x squared. So I need to make sure I have a 0x squared when I write it, when I do my long division. Okay, so I have 3x to the fourth minus 5x cubed plus 0x squared plus 4x minus 6. And all of that is divided by x squared minus 3x plus 5. Okay, so then when we start, we're going to look at 3x to the fourth divided by x squared. What is that going to leave me with? 3x squared. So I write that 3x squared over its like term in the dividend. And then I multiply. 3x squared times x squared gives me 3x to the fourth. 3x squared times negative 3x is a negative 9x cubed. 3x squared times 5 is 15x squared. Okay, so when I subtract, what do? Change your signs. This becomes a negative 3x to the fourth plus 9x cubed minus 15x squared. So 3x to the fourth minus 3x to the fourth cancels. Negative 5x cubed plus 9x cubed gives me 4x cubed. 0x squared minus 15x squared leaves me with negative 15x squared. And I bring down the plus 4x. And then I do another round. 4x cubed now divided by x squared leaves me with what? 4x. So I put a plus 4x and I multiply. So 4x times x squared is 4x cubed. 4x times negative 3x is a negative 12x squared. 4x times 5 is 20x. And I'm going to subtract the entire thing. Okay, so I change my signs because I'm subtracting. Negative 4x cubed plus 12x squared minus 20x. So my 4x cubed cancels. Negative 15x squared plus 12x squared leaves me with a negative 3x squared. And then 4x minus 20x is a negative 16x, and I bring down my minus 6. Then I do another round. I take that negative 3x squared and divide it by x squared. And that leaves me with negative 3. So then negative 3 times my entire divisor is going to give me a negative 3x squared plus 9x minus 15. And I subtract that. I change my signs. And so my 3x squared cancels. Negative 16x minus 9x leaves me with a negative 25x. And then negative 6 plus 15 gives me a plus 9. So this is where I can't go any further because with my remainder, this has a degree that is less than my divisor. I have an x, but my divisor was x squared. I also look at the fact that I went all the way to my constant and my quotient. So this, even though it's two terms, will be my remainder. The 3x squared plus 4x minus 3 is my quotient. And then the x squared minus 3x plus 5 is the divisor. So when you write your answer, you copy that 3x squared plus 4x minus 3. But what happens whenever I go to do my remainder over my divisor? Okay, this is a negative. So when I bring this negative out, I have my 25x, but what happens with this 9? can I just move this negative out front and leave a plus 9 there? No, because you would be subtracting the entire thing. So when you take this negative and you put it right here, you're really factoring out a -1, and that leaves me with 25x, now a -9. So you have to be careful if you have a negative with multiple terms. You have to take that negative out like a GCF, and then that 25x minus 9 will be my remainder in my answer. Okay, and then we have our x squared minus 3x plus 5. Okay, do we have questions on long division? Because those are our only two examples for long division. The rest is synthetic. Okay. Okay. Synthetic division is another method to divide polynomials. You can only do synthetic division with a linear divisor, so that means if you're dividing by something with x, not x squared, not x cubed, just x. You also can only do it when that divisor has a coefficient of 1. Okay, so if, the word if should be there. If the divisor has a coefficient greater than 1, then you have to divide the entire function by that leading coefficient. Because you cannot start your synthetic division until that divisor has a coefficient of 1. Okay, so if you have 2x or 3x or 5x, something like that, you're going to have to divide everything by that coefficient to make that linear divisor a coefficient of 1. Then you can do your synthetic division. Okay, now synthetic division is only going to deal with your coefficients. It's very quick. The concept of synthetic division is not hard. What is challenging for some people is that there are about 4 different sections that you're going to be doing synthetic division with. So you have to know your instructions and what you should be doing based on those instructions. Okay. So if all it says is divide using synthetic division, it doesn't tell me anything else other than divide, your answer is still going to be in that quotient plus remainder over divisor format. Okay, so my first example, I have 2x cubed plus 3x squared minus 15x minus 16, all divided by x minus 3. So once you get that, you're still going to check, is it in standard form? You're still going to check, am I missing any terms for me to do a placeholder? Okay. Once you do that, once you check for everything, you're going to take this divisor, x minus 3, and you're going to set it equal to 0 to get an actual x value. So if I have x minus 3 equals 0, I would add my 3, and x equals 3. That is the number that when you set up your synthetic division, it goes in onto the left, the farthest left, and it has its own little spot. I call it a little cubby. Okay, it has its own little spot. So then you're going to take all of these coefficients, as long as it's in standard form and you're not missing terms, you're going to take those and you're going to line them up in the same row as that number you're dividing by. Okay, so then what I'm going to do is I'm going to leave some space and I have a line. And then your first step, once you set it up, is bring down your 2. Whatever number that is, you always bring it down. Okay, then this number that's over here, you're going to take and you're going to multiply it by whatever number is underneath this line. So 3 times 2 is 6. I'm going to put that 6 underneath that very next term. And I'm going to add vertically. So 3 plus 6 would give me 9. Then I do all those steps again. I'm going to take 3 and I'm going to multiply it by 9. 3 times 9 is 27, and I put that underneath the negative 15. I'm going to add negative 15 plus 27, and that gives me 12. Then I'm going to multiply 3 times 12. That gives me 36. I put it underneath the next term and I add. Negative 16 plus 36 leaves me with 20. This last number is your remainder. Okay? So what does the 2, 9, and 12 give me? Well, when you do your round of synthetic division, this is considered one round. Okay? You're going to take your original degree and you decrease it by 1. So if I started with x cubed, I've decreased it. Now it's going to be x squared. So the 2 is the coefficient of x squared, 9 is the coefficient of x, and 12 is your constant. So you just take it and put it in standard form. So this tells me that I have 2x squared plus 9x plus 12 plus my remainder of 20 over my divisor. My original divisor was x minus 3, so I put it as x minus 3, not 3. And then that is my answer. So synthetic division is much quicker than long division. It's much easier, but you can only do it with a linear factor. So that second example of long division that we had, you could not do synthetic division with. Okay? Do we understand those steps and where I got the numbers from? We're okay? So our next example, I have 4x to the 4th minus 5x squared plus 2x plus 4. And that's being divided by 2x minus 1. Okay? So because I am dividing by a linear factor that has a coefficient greater than 1, I have to divide everything by that coefficient. So I'm going to divide everything by 2. Okay, so when I do that, that now becomes 2x to the 4th minus 5 halves x squared plus x plus 2 divided by x minus 1 half. Every single term in your dividend and your divisor gets divided by 2. Then you're able to set that divisor, x minus 1 half equal to 0. Add your 1 half, x equals 1 half. So that 1 half is what goes over to the side in its little cubby. And when I look at my dividend, what should you notice? You're missing x cubed. So when I line up my coefficients, I'm going to have 2 for the x to the 4th, but I need to put my 0 for x cubed. Then my negative 5 halves, my 1, and my 2. And then you're able to start your division. So I bring down my 2. 1 half of 2 is 1. 0 plus 1 is 1. Half of 1 is 1 half. Negative 5 halves plus 1 half is going to give me a negative what? Negative 4 halves, which is a negative 2. Then half of negative 2 is negative 1. 1 minus 1 is 0. Half of 0 is 0. And so that leaves me with 2 as my remainder. Okay? So if I started with x to the 4th, this makes this 2 become the coefficient of x to what power? If I started with x to the 4th, it comes down to x cubed. So I have 2x cubed plus x squared minus 2x. I do not have a constant. Okay, when I write this plus 2, that was the divisor that gave me x minus 1 half. Okay, but there's two things about this. X minus 1 half has a fraction in the denominator, and I'm never going to have that as a proper answer. So 1, I can't have a fraction in the denominator, and 2, my original divisor was 2x minus 1. So I need to take care of this fraction, and I need to make it 2x minus 1. What do I do with this to get it the 2x minus 1? I multiply it by 2. So what I do to the denominator, I have to also do to the numerator. So I bring down my quotient, 2x cubed plus x squared minus 2x, plus it's now going to be 4 over the 2x minus 1 divisor that I started with. So if you have a divisor that has a leading coefficient, you divide everything by that in step 1, and then at the end, if you have a remainder, you have to multiply it back in to get your original divisor. Does that make sense? Okay. So are we good with that? All right, so that's with just dividing. Then we're going to look at the factor theorem. Okay, the factor theorem tells you that if you do your round of synthetic division and you get a remainder of 0, then that divisor is a factor of that polynomial. Okay, so if I'm telling you, given a polynomial and one of its factors, I'm telling you it's a factor, you absolutely should get 0 as your remainder. If you don't, then you need to redo your math. Okay, so the instructions I have fill in the blank because I need you to understand the difference between each section from this point forward. Okay, because your instructions are going to look the exact same except one word. Okay, and if you don't pick up on that, then you're going to do possibly the wrong thing in the wrong section. Okay, so given a polynomial and one of its factors, use synthetic division down to a quadratic, then find the remaining factors. Say all the factors. So what do you think we're going to be doing? Factoring. Okay, so show all required work. So our first example that we have is x cubed plus 5x squared minus 12x minus 36. And then I'm telling you x minus 3 is going to be one of the factors. So when I tell you, given a polynomial and one of its factors, that x minus 3 is a factor. Okay, so I can still set that equal to 0 and get my x equals 3. So the 3 still, my steps are still the same as far as synthetic division goes. It's just going to be when you finally get your quotient, what you do with that afterwards. Okay, so I'm going to bring down my 1, 5, negative 12, and negative 36. And then I'm going to bring down the 1. 1 times 3 is 3. 5 plus 3 is 8. 3 times 8, 24. Negative 12 plus 24 is 12. 3 times 12 is 36. There's the 0 that I need. Okay, because it's a factor, it's perfectly divisible. I should not have a remainder. So if I started with x cubed, this is now telling me I have x squared plus 8x plus 12 equal to 0. Don't equal it to 0. I'm thinking of the next section. This is exactly what I don't want you to do. That's why I'm thinking of it. So when it just says factors, you just write your quotient and you factor it. Okay? So factors of 12 to give me 8. What would that be? 6 and 2. So x plus 2, x plus 6. Or you can do the 6 first, the 2 second. It doesn't matter. But because it also says state all of the factors, you also have to take that x minus 3 and include that in your answer. So whatever you start with that I give you is also part of your answer. Okay. So our next example, we've got 3x cubed minus 2x squared minus 61x minus 20. And I'm giving you 3x plus 1 as a factor. So what do I need to do with that? Divide everything by 3. So that leaves me with x cubed minus 2/3 x squared minus 61/3 x minus 20/3. And then my factor is now x plus 1/3. So if x plus 1/3 is my factor, I set that equal to 0, I get x equals negative 1/3, and that is the number that goes to the side. Then I have my 1, negative 2/3, negative 61/3, and negative 20/3. Okay, so then I bring down my 1. Negative 1/3 times 1 is a negative 1/3. Negative 2/3 and negative 1/3 gives me negative 3/3, which is negative 1. Negative 1/3 times negative 1 is a positive 1/3. When I combine that with negative 61/3, it gives me negative 60/3, which is negative 20. Multiply that by negative 1/3, and I get a positive 20/3, which gives me the 0 I need. Okay. So if I started x cubed, this is now x squared. So I've got x squared minus x minus 20. My remainder is 0, so I don't have to worry about multiplying anything by 3. What does that factor to? Factors of 20 to give me a negative 1. X minus 5 and x plus 4. And then you also include your original factor of 3x plus 1. Okay, so when I tell you I'm giving you a factor, everything that you get for your quotient should be factorable. Okay, are we good with that section? All right, so now instead of me saying I'm giving you a factor, now I'm giving a polynomial and one of its zeros. So that one word changes what you're going to do after you get to quotient. Okay, so you have to know what to do when. It says use synthetic division to get the function to a quadratic, then factor. You're still factoring, but you have to find the remaining zeros. You're no longer finding just the factors, you're finding the zeros. If the quadratic cannot be factored, anytime I can't factor something, what do I default to? The quadratic formula. Now, there are some instances where you can use square roots, but most of the time you're using quadratic formula to find the remaining zeros. Okay, so what's the difference between a zero and a factor? What does a zero mean? Your x-intercept. So your zeros are your x-intercept. So your factors are what can be multiplied to give you your polynomial. Your zeros are your solution of the polynomial. So if I have the word 0 in your instructions, you set it equal to 0 and solve for each x. So that's what I was thinking about whenever I put equals 0 up there. You only do it when the 0 is in your instructions, okay? Your answers should not be in factored form. They should be x equals a number, okay? When it says factor in your instructions, your answer should be in factored form. 0 should be your x values, okay? So all the same steps apply. If I have f of x, because it's a function now, I'm finding zeros. F of x equals x cubed plus 2x squared minus 9x minus 18. And I give you a negative 2. So I no longer have an x with it because I'm telling you that is the x value. That is telling me x equals negative 2. I do not change the sign. I take that number, negative 2, and I put it over to the side. And then I copy my 1, 2, negative 9, and negative 18. Bring down your 1. Negative 2 times 1 is negative 2. Combine that with 2 to give you 0. 0 times negative 2 is 0. That leaves me with negative 9. Times negative 2 is a positive 18, which gives me the 0 I need. Okay? What is my quotient? What does this 1, 0, negative 9 tell me? What am I left with? X squared minus 9, and I set it equal to 0. Okay, can I factor x squared minus 9? Yes. Missing the concept that this is the difference of two squares is going to lose you some credit, okay? What happens is most people add 9, take a square root, give me plus or minus 3. While that is okay to solve it that way, sometimes you are in chapter 5 where we're testing can you factor it. Okay, so you have to recognize that's a skill. You have to be able to analyze and recognize that it's the difference of two squares. So this will factor into x plus 3, x minus 3 equals 0. So then x plus 3 equals 0, x minus 3 equals 0. That gives you x equals negative 3 and x equals positive 3. Then you also bring down the x equals negative 2. Okay? So the only difference is you take it further, you set it equal to 0 and actually solve that back to the form. Okay? We good with that? All right, this next example, we have f of x equals 8x to the 4th plus 32x cubed plus x plus 4. And I give you a negative 1/2. If I have a negative 1/2, what do I need to do? What did I have to do to get a negative 1/2? I had a coefficient greater than 1 for me to have a fraction, right? Because when we were doing it with the divisor and you had a coefficient greater, you had to divide it, and that's how you get a fraction here. So for me to have a negative 1/2 or any fraction as a 0, whatever that denominator is, you're going to take that function and divide by that denominator. So we're going to divide our function by 2. So we're going to take that f of x equals, it's now going to be 4x to the 4th plus 16x cubed plus 1/2 x plus 2. So I take that negative 1/2. When I bring down my coefficients, what do I need to also account for? The missing term for 0x squared. Okay, so I'm going to have my 4, my 16, my 0, my 1/2, and my 2. So I bring down my 4. Negative 1/2 of 4 is negative 2. 16 minus 2 is 14. Negative 1/2 of 14 is a negative 7. 0 and negative 7 is negative 7. Negative 1/2 of negative 7 is a positive 7/2. Combine that with 1/2, and you get 8 over 2, which is 4. Negative 1/2 of 4 is a negative 2, which gives me the 0 I need. Okay. Now, I started with x to the 4th, so what does this give me? X cubed. My instructions say get it down to a quadratic. X cubed is not a quadratic. So what we're going to have to do is we're going to have to get another 0 from the graph of that function. So you're going to get another 0 from the graphing calculator. I'm just going to put from the graph. So if you start with a degree that's higher than 3, I'm only giving you 1 0. So that means I have to find another one to get it down to x squared. Okay, so what we're going to do in our calculator is we get the original function and we graph that. So 8x to the 4th plus 32x cubed plus x plus 4. So you do the original function, not the one we divided by 2. If you notice in the graph, that negative 1/2 that I gave you is the negative 1/2 that's here. Okay, so I can either count and find that 0, or how else can I use my calculator to find the 0? Mini 6 enter, that was 5.1. Okay, so mini 6 enter, I get a dashed line. Remember, you bring it to the left of that x-intercept and click the center button and scroll over to the right. That point will pop up. So that 0, -4, 0, that -4 is what I'm going to use for my next round. So that is from the calculator. And then I'm done with the graphing calculator. I don't use it again. Okay, all I need is to be able to graph it and get my 0. Do we have questions on that? We're good? So you bring down the 4. -4 times 4 is -16. 14 and -16 gives me -2. -4 times -2 is 8. -7 plus 8 is 1. -4 times 1 is -4, which gives me the 0 I need. Okay, so now we've got 4x squared minus 2x plus 1 equals 0. Can I factor that? If I try to, I would multiply 4 times 1, get 4, factors of 4 to give me 2. I'm not going to get that. So if it's not factorable, what do? Quadratic formula. Okay, so my A is equal to 4, my B is equal to -2, my C is equal to 1. So 4AC is equal to what? 16. So I have x equals negative b, so -2, plus or minus the square root of b squared, which is -2 squared, minus 16 all over 2 times 4. So I get x equals -2 gives me a +2, plus or minus the square root of. What do I get under the radical? -2 squared is what? -2 squared is 4, minus 16, -12, all over 8. Okay, so what do I do with that -12? Break it down. Okay, so I've got a 12, that splits 2 and 6, 6 splits 2 and 3. So I have a pair of 2's with a 3 left over. So I've got 2 plus or minus what? 2i squared is 3, good. All over 8. Then what happens with that? Divide it by 2, so x equals 1 plus or minus I square root of 3 over 4. So that's my answer whenever I do quadratic formula. What is the remaining part of my answer? If I have to state all the zeros, what do I also have to include? X equals -1/2. And x equals -4. Okay, are we good with that? Okay. So now we're going to look at what happens if I give you an imaginary root. Okay, so if I have f of x equals x cubed plus 7x squared plus 25x plus 175, and the zero I give you is 5i. Okay, I have the same steps, I just have 5i over to the side. Okay, so I would space this out a little bit further than what I did here because you're going to have I throughout your problem. Okay, so I have my 1, 7, 25, and 175. My steps are still the same, bringing down my 1. 1 times 5i is just 5i. What happens when I add 7 plus 5i? It's just 7 plus 5i. I cannot make that 12i because they're not like terms. Now, we've already talked about complex numbers, which is your real and imaginary. So I expect you to write it in standard form of a complex number, which is your real plus your imaginary. Imaginary always comes second, okay? Because you have that, that's why I say to space it out, okay? So now when you multiply, you have to take that 5i and distribute it to the 7 and the positive 5i. I would recommend doing that over to the side so you don't make mistakes. So 5i times 7 gives me 35i. 5i times 5i gives me what? 25i squared. And what do we know about I squared? It's a -1. So that 25i squared is really a -25. So I have -25 plus 35i when I write it in standard form. So -25 and 25, when I combine that, cancels, and I just have 35i to write down. So then I multiply 5i times 35i. 5 times 35 is 175, and then I squared. So 175i squared is -175. That gives me the zero I need. So I have the zero that I need, but if I wrote down coefficients here, I would have complex coefficients with imaginary terms, which I cannot have with a function, okay? No quadratic is going to look like that. So what is the only term that's going to be able to get rid of those i's? If I start with 5i, what is always going to go with it? Not just I. And -5i. I have to use the conjugate to get rid of the I. Okay? So if I use the conjugate, if I start with 5i, you have to understand the negative goes with it. If I start with a negative, you have to understand that the positive goes with it. You always have to do the conjugate. Okay? So I'm going to bring down my 1. 1 times -5i is a -5i. That cancels, giving me 7. -5i times 7 is a -35i, which gives me 0. If you do your problem and you still have i's down here after you've done your 2 conjugates, you need to go back and redo your math. The whole point of doing the conjugate is to cancel out that I and have real coefficients. Okay, so if I started with x cubed, this one round knocked it to x squared, so this is now just x plus 7 equals 0. Subtract your 7, x equals negative 7, and x equals plus or minus 5i. Okay, do we understand that? Okay, now, as much as I would love to move on, because I know y'all understand synthetic division, you have to look at what happens when instead of just a 5i, you have a complex 0. Okay, so if I have f of x equals x to the 4th minus 9x cubed plus 24x squared minus 6x minus 40, and now I give you 3 minus I. Okay, I'm still going to set it up 3 minus I over to the left. I have my 1, negative 9, 24, negative 6, and negative 40. I bring down my 1. 3 minus I times 1 is 3 minus I. Negative 9 plus 3, because I can only do my real terms. Negative 9 plus 3 gives me negative 6, and I bring down the minus I. Now, when I multiply, I have to do 3 minus I times negative 6 minus I over to the side because I have to FOIL that. Okay, so I have 3 times negative 6, which is negative 18. 3 times negative I and negative 3i. Negative I times negative 6 is a positive 6i plus I squared. Okay, that I squared is a negative 1. Negative 18 minus 1 is negative 19 plus 3i. So negative 19 plus 3i goes lined up with the 24. So then 24 minus 19 gives me 5 plus 3i. Then I multiply again. 3 minus I times 5 plus 3i. So when I FOIL that, 3 times 5 gives me 15. Then plus 9i minus 5i minus 3i squared. The minus 3i squared turns to what? Plus 3. 15 plus 3, 18 plus 4i. So negative 6 plus 18 gives me 12 plus 4i. And I have to multiply again. So 3 minus I times 12 plus 4i gives me 36 plus 12i minus 12i minus 4i squared. That negative 4i squared turns to plus 4. The 12 i's cancel, so that leaves me with the 40. That gives me the 0. Again, if you don't get a 0 right there, you need to redo your multiplication. Okay? Now I've done the 3 minus I. What am I going to do to cancel out these i's that are still remaining? 3 plus I, the conjugates. Now you should know those i's cancel out, so you're not going to have all of this long FOILing to do anymore. Okay, so 3 plus I. When I do that with the negative 6 minus I, the i's cancel, leaving me with negative 3. Negative 3 times 3 plus I gives me a negative 9 minus 3i. I's cancel, leaving me with negative 4. Negative 4 times 3 plus I gives me negative 12 minus 4I. There's the 0 I need. So what do I have remaining? X squared minus 3x minus 4 equals 0. Can I factor that? Mm-hmm. What does that factor to? Okay. So x equals positive 4, x equals negative 1, and x equals 3 plus or minus I. Do we have questions? These are long notes because you have so many different scenarios, okay? But do we understand what we're doing? Okay. All right, remainder theorem. This is your fourth section with synthetic division, okay? You have to know that when I say use the remainder theorem or synthetic substitution to evaluate the function for the given value, you have to know what that means, okay? So what the remainder theorem is telling you is that you can use a 0 or any given value, and when you do synthetic division with that, your remainder is the value of that function for that specific x value, okay? So if I give you f of x equals x cubed minus 2x squared plus 3x minus 7, and I tell you x equals negative 1. If it says remainder theorem or synthetic substitution, and you just do f of negative 1 equals, don't write this, just look, negative 1 cubed minus 2 times negative 1 squared plus 3 times negative 1 minus 7, and get a value, I'm not giving you credit. Because that's not what your instructions tell you. That's what I get most of the time. Because you don't know your instructions. Okay? So what this is telling me is I have a negative 1, and I do my synthetic division. So I have 1, negative 2, 3, and negative 7. Bring down my 1. I get negative 1, which leaves me with negative 3. When I multiply that, I get a positive 3, which leaves me with 6. Multiply that, get negative 6. Now I have a negative 13 as my remainder. Some people will do that and then tell me x squared minus 3x plus 6 plus negative 13 over negative 1, which is not what I'm asking. I'm asking you to evaluate the function for that given value. So that means f of that x value, negative 1, equals your remainder, negative 13. So this is just showing you that you can use synthetic division, and remainder theorem is another way for you to find the value of the function. Okay? We good with that? All right, last two examples. Okay? This is when I'm going to give you zeros and I ask you write a polynomial function with real coefficients. I don't know what the rest is. I don't know that off the top of my head. It'll say them in your worksheet. But what is important is that it says write a polynomial function. So you have to have f of x equals each step of the way. That's how you're notating it's a function. Okay? So what I give you are just numbers. So 3, 0, and 4i. You're going to have your instructions, and you're just going to have numbers. It could be 2, or it could be 3. It could be more, but I don't think I do any more than that. Okay? So what this is telling you x is equal to 3, x is equal to 0 and x is equal to 4i. If x is equal to 4i, what do I also have? Its conjugate, negative 4i. So you have to understand that. So for us to be able to write a function, we have to put these zeros into factored form. So usually what you do is you factor something and then get it equal to your x, right? What we're doing is reverse. So if my final answer would have been x equals 3, what should factored form look like? I move that back over with the x, so it would be x minus 3. Now, when I have x equals 0, there's nothing to move over. So I just have an x, and I put that in the front. Now, this x equals 4i, when I move that back over, it should become x minus 4i. And when I have x equals negative 4i, that becomes x plus 4i in factored form. Now, if I covered up this function and I just gave you this, what would you do? Or distribute and multiply. That's what you're doing. Okay, so your first step is being able to put it in factored form. And then from then, you just multiply and clean up. So this x times x minus 3 can become x squared minus 3x. The x minus 4i and the x plus 4i, what do I know about those? They're conjugates. What is my conjugate formula? If I have a plus b times a minus b, a squared minus b squared. So that's the first term squared minus my second term squared. We've done this. Okay, so in parentheses, my first term is x, so x squared is x squared. Minus, I take a 4i and I'm squaring it. That does not give me 4i squared. That gives me 16i squared. What do I know about negative 16i squared? What does that turn into? A positive 16. So I have x squared minus 3x times x squared plus 16. Now I just multiply. X squared times x squared is x to the 4th. X squared times 16 is 16x squared. Negative 3x times x squared is negative 3x cubed. Negative 3x times 16 is a negative 48x. Can I box that? Why not? It's not in standard form. So f of x equals x to the 4th minus 3x cubed plus 16x squared minus 48x. Okay, are we good with that? Okay. Now my last example, I give you negative 2/3 and 3 plus I square root of 2. So this tells me x equals negative 2/3. And this tells me x equals 3 plus I square root of 2. And if I have that, what do I also have? Very good. 3 minus I square root of 2. Now, we cannot write factors as fractions. Okay? How do I get a fraction as a 0? What had to happen? You had an actual coefficient. Okay? So if I go in the opposite way, I would have to multiply both sides by 3, and that would give me 3x equals negative 2. Whatever that denominator is, you multiply it to the x, and then you move that negative 2 over. So this is really f of x equals 3x plus 2. Okay, so if I give you a fraction, that denominator was really the coefficient of x if you work in the opposite way. Okay? Now, when you have this 3 plus I squared root of 2, you're going to move the 3 and the I squared root of 2. So you cannot get rid of that x. That's what I see often. You have x, then minus 3 minus I squared root of 2. Then when I have the 3 minus I squared root of 2, I move the 3 over and the negative I squared root of 2. So that becomes x minus 3 now plus I squared root of 2. Okay. So knowing this, is there anything you recognize here? It's pretty much the same thing, right? Except what? I have x minus 3 and x minus 3. That's the same. And I have I squared root of 2 and I squared root of 2. That's the same. It's only the sign in the middle. So if only my sign in the middle changed, what does that tell me those are? I can view those as conjugates to make my multiplication easier. It might not seem like it would be easier, but that's better than taking x, multiplying it 3 times, taking negative 3, multiplying it 3 times, and taking I squared root of 2 and multiplying it 3 times. Okay, so what we're going to do is how do we multiply this as conjugates? So I'm going to have brackets just because I know my first term, if I've circled it the way this is, my first term is considered to be x minus 3, and I'm going to square that. Because my conjugate formula tells me if I have a plus b and a minus b, that's a squared minus b squared. So my a is this x minus 3 squared. Minus my b would be I squared root of 2 squared. Okay. So if I copy down f of x equals 3x plus 2, when I take x minus 3 and square it, I can use the formula that we looked at in 5.2. If I have a binomial squared, that formula, if I have a plus b squared, that's your a squared plus 2ab plus b squared. I remember that? And if I had a minus, then this term was a negative. That's the only thing that changed. So if I have x minus 3 squared, I can go straight to x squared minus 6x plus 9. Then I bring down the minus. Don't miss that. If I take I square root of 2 and I square it, that means I'm multiplying it by itself. Some of you might have to actually write it multiplied by itself to see what's happening. Square root of 2 times square root of 2 is what? 2. And then I times I is I squared. Now, a negative 2 I squared is really a plus 2. So I have f of x equals 3x plus 2 times x squared minus 6x plus 9 plus 2 will give me 11. And then I multiply. F of x equals 3x cubed minus 18x squared plus 33x. And then 2x squared minus 12x plus 22. So when I combine everything and put it in standard form, what should my final answer be? Good. Very good. Okay. Are we all good with that? You have questions? Okay.